all you have to do is just get.
Okay, let's see. This one is kind of a little bit different than the other ones, but I think if you look at it long enough, you'll see what to do. You one person see it. There are many. So right now, it looks like, yeah. How do you make sure that when you add them together, one of the variable goes away when it's like this? Seems like you can't really multiply, right? There isn't a number you can multiply the bottom one or the top one to get rid of it. So what are you gonna do, Nathan?
You multiply both of them.
You multiply both of them, meaning?
You multiply the top one by
Yeah,
3.
yeah. If you can multiply one of the equation by same number, why not? Can't you then multiply some number to the other ones too?
Yeah.
So which numbers would you multiply? The top and the bottom. There are actually two cases you could do this. Scott, what would you do?
Top one by 2.
Top one by 2.
Bottom one by 5.
Bottom one by 5. Then if you do that, don't you get rid of the
Why?
y, right? Is that the only way to do that? Or, that's totally fine, you can do it that way. Or, Berge, what would you do?
Top one by 3.
3.
And the bottom one by -4.
Bottom one by -4, that will work. Which one's better?
3, 4.
You think it's better to multiply 3 and -4? No, I like 2 and 5 because then it doesn't involve any negatives. Isn't that better? It doesn't really matter. I did it twice. So you could either do it this way where you multiply top one by 3, of course, to both sides of the equation, and then the bottom one by -4 on the both sides. Or, you see what I did over here? You can multiply top one by 2 and bottom one by 5. I like this one better because it does not, you don't have to deal with negative numbers, you see, when you distribute. But it's the same thing. Go ahead, everybody try, see what you get. Okay, so either one of those way, you should all get the same answer. Let me show you how I did. Then I did the 3 times -4. So when you do it, don't you get positive 12x minus 15y equals 9, and then negative 12x minus 8y equals 60? Yeah. So as you can see, that you have 12x and you have negative 12x. That's why you want to add, and then you get rid of all the x's. Then you get, don't you get negative 23y equals to 69? Then you divide both sides by negative 23. You get negative 3. Now, how many people did it this way on the right? Okay. What did you guys get when you solve for y here? I mean, when you solve for x? Y equals to negative 3, right? So if you did it this way, that's totally fine. Okay. So let's just look at this one first. Okay. So then, what do I do next? I know that y equals to negative 3. How do I find x? You plug into one of your original equation. What did you get? Did anybody get the answer when you plug it in? What did we get as the x? How about Stephanie? Oh, negative 3, right? Don't you get negative 3? And I could kind of tell because I got negative 3 on this one. So, how many people got negative 3 as your answer? Very good. Any question? So there are 2 ways of doing this, right? Really. Caleb, did you have a question?
No, I was just raising my hand because I got it right.
Oh, okay, very good. Any other question then? No? Are we good? Okay, so this section is pretty simple, isn't that right? Pretty straightforward. Okay.
Pretty straightforward.
So I want you to think about this. This is kind of like getting a common denominator, isn't that right? Imagine that you had guys, listen. Like if you have denominators 4 and 3, what's the LCD of 4 and 3? 12, you see? That's what we're really doing. It's kind of same idea like that.
Isn't it in that situation the substitution method might have been easier?
I don't think so, because you're gonna get a bunch of fraction if you solve for one of the variable.
Oh, but I mean if you weren't getting a fraction.
Yeah, sometimes substitution method is nice. Yeah, I mean, once you get a simple equation. Okay, now what if I give you this? Let's see who's really thinking. This is not that bad. So, I have fractions in my equation. What do you think I should do first? Because I don't want to deal with fractions. Dieter. That's correct. Multiply the equation with fraction, both sides by the LCD, which happens to be this time 2, correct? Because once you do, you can get rid of the fraction easily. So every time you have an equation with fractions, multiply both sides by the LCD to make it simple. So you get something like this, don't you? As you can see, I don't want to multiply. Guys, do you think it's a good idea to multiply both sides of this by the LCD? Reciprocal? No, even though this will be x, what would happen to y? You still have a fraction. The only reason why we multiply both sides by the LCD is so that we don't want to get any fractions, right? Go ahead. Now, what are you going to do with this? We got 3x plus 2y equals 12, and x plus y equals to 5. What should we do next? multiply the bottom two. Yes. -3 or -2, correct? So you could do either way. It doesn't matter. I did it both, I think. So let's just stick with -2. It doesn't really matter. Okay, go ahead, guys. Finish it. Okay, so once you multiply both sides by 2, don't you simply get, let me hide this part. So, don't you get 3x plus 2y equals 12? And then, of course, that stays the same. And then bottom, you get -2x plus -2y equals to -10. And, of course, now we're ready to add because it will cancel out the what? Which variable would it cancel out? Y. So we get x equals to what, class? 2. How many we got x equals to 2 there? Okay, good. And how do we find the y? We simply plug it in. Okay, so when you do, you get, I choose the, of course, obviously the easier equation, right? X plus y equals 5, so y is 3. How many people got y equals 3 there? Very good. Now, did anybody try multiplying -3 to both sides to get rid of the x? No, it's fine. You could totally do that. Berge, did you get the same answer? Oh, you didn't? Okay. If you do, you still get the same answer. You see on the right? It doesn't matter how you do it, okay? You still get the same answer. Okay, any question?